Hey guys, it's good to have you back on Step by Step Academy. Today we will be looking at the subtraction of numbers in any given base. Before we go ahead to illustrate the concepts with the following examples on the screen, I'd like us to do a quick recap on how to perform the normal subtraction. Please note that the normal subtraction of numbers are usually in base 10. Take for instance, suppose I have 36 minus 27. If I were to subtract these two numbers, note that the normal subtraction is in base 10. Now if I were to subtract these two numbers, the first thing I would have done is to borrow 1 from 3, and that will leave us with 2. Now we place the 1 in front of 6. The 1 combines with 6 makes 16. Then we go ahead to do 16 minus 7, and that will give us 9. This would have been our answer if we were to subtract in base. Now I like to draw your attention to something, that is not by placing the 1 here in front of 16, in front of 6 rather, that actually makes the 6 16. It is because the operation is in base 10, and whenever we borrow 1, the 1 automatically becomes 10, and then 10 plus 6 will give us 16. So this same concept is applicable to whatever number base you have. For instance, suppose I have 23 minus 14 in base 5. Now if I were to subtract this number, 3 minus 4 is impossible. So what I would have done is to borrow 1 from 2, and that will leave us with 1. Now the one I borrow from 2 automatically becomes 5 because the operation is in base 5. Then 5 plus 3 will give me 8. So 8 minus 4 will give us 4. This is how you subtract numbers in any given base. So the most important thing to take note when subtracting numbers in any given base is to know that whenever you borrow 1, the 1 automatically becomes the base you are operating in. If I borrow 1 in base 5, the 1 becomes 5. If I borrow 1 in base 6, the 1 becomes 6. If I borrow 1 in base 7, the 1 becomes 7. If I borrow 1 in base 12, it becomes 12. If I borrow 1 in base 16, the 1 automatically becomes 16. So this concept is applicable in subtracting numbers in any given base. Now, having said that, let's now go ahead and apply this concept to the following examples. Number 1, we have 11011 base 2 minus 1001 base 2. Now 1 minus 1, we can subtract this without borrowing, so 1 minus 1 will give 0. 1 minus 0, we can also subtract this without borrowing, that will give us 1. 0 minus 0 will give us 0. 1 minus 1 will give us 0. 1 minus nothing, that will still give us 1. So this was quite easy. Our answer to this is 10010 base 2. Now come to the second example. Here we have 5 minus 3. 5 minus 3 is possible without borrowing. So 5 take away 3, that will give us a remainder of 2. Now we come to the next one, 1 minus 4. 1 minus 4 here is impossible. So we will have to borrow 1 from 5, and the 5 automatically becomes 4. Now the one we borrow becomes 6 because we are operating now in base 6. So 6 plus 1 will give me 7. 7 minus 4 will give me 3. 4 minus 2 will give us 2. And then 2 minus 1, that's possible without borrowing, that will give us 1. Therefore our answer to this will be 1232 base 6. Now to the next example, we have a minus 2. Remember, in our hexadecimal number base system, letter A is 10. 10 minus 2 is possible without borrowing. That will give us 8 base 13. 3 minus 3 will give us 0. Now 2 minus 3 is impossible, so we will have to borrow from B. Now remember that letter B stands for 11. So if we borrow from B, the B becomes A, that is 10. The one we borrow automatically again becomes the base because we are in base 13. So 13 plus 2 will give us 15. And then 15 minus 3 will give us 15 minus 3 will give us 12. What letter again is 12 in base 16? Yes, that's letter C. Letter C is 12. So our answer to this question is CO8 base 13. And next, to the next example, we have 2 minus 4. So 2 minus 4 is impossible. We will have to borrow from the next digit. So if we borrow 1, the 1 becomes 5, because we are in base 5. So 5 plus 2 will give you 7. 7 minus 4 will give you 3 in base 5. 3 minus 2 is possible without borrowing, that's 1. 3 minus 1 is possible without borrowing, that's 2. And 1 minus 1, that will be 0. Therefore, our answer is 213 base 5. 4 minus 7. So here 4 minus 7 is impossible, so we'll have to borrow from the next digit. So we borrow from 2, that will be 1. The 1 we borrow automatically becomes the base, which is 9. So that gives us 9 plus 4, which is 13. 13 minus 7 will give us 6 base 9. We borrow 1 again. 1 minus 3 is impossible. We borrow 1 from 7. That will leave us with 6. The 1 we borrow from 7 automatically becomes the base again. That's 9 plus 1. 9 plus 1 will give us 10. 10 minus 3 will give us 7. 6 minus 7 again is impossible, so we borrow from 3. That will leave us with 2. The 1 we borrow from 3 becomes the base again, which is 9. So we have 9 plus 6. 9 plus 6 is 15. 15 minus 7 will give us 8. Then we have 2 here. 2 minus nothing, that will give us 2. Therefore, our answer to this in base 9 is 2876 base 9.